Hello, GPU Marcus. Hello, everybody. Hello, hello. Do. Uh, so I've been working on things. Nothing flashy, but I took a look at all the flows related um to audio calls. Um, and I think we're in a pretty decent shape in the sense that I have high confidence, well, relatively high confidence that we can have long calls and we can expect them to pretty much just work fine for everybody. There are still improvements that could be made to the jitter buffer, like a few, I would say, fairly critical ones. Also, server side. I think that server side as well might not be a bad idea to um, maybe make the sending mechanism a little bit more sophisticated. Maybe, I don't know. Debatable. In any case, so there are there's space for improvement still, but where we are is like already pretty good. I would say we are 90% of the way there. Like it's the remaining 10%, not even 20, just 10% that remains for audio stuff. Audio though. Um, what about video? I started getting curious about video. I wanted to polish existing workflows before getting into video, and I did that for a couple of days. So I did some of that work. Um, Originally, I was planning to do more, polishing slash janitorial work. But audio is in decent shape, and now I'm just so curious about getting video to work. So yeah, that's kind of what I want to look into. What I want to look into next. We have screen capture, we have webcam capture, but right now we don't know what to do with that video. So like we don't know what to do with those video streams. Also, um, video capture is giving us like BGRA frames. What if there is a way to get the video already compressed, and also which algorithms should use for compression, etc. So there's a few interesting questions there. Um, in any case, I'll be right back in a second. I'm just gonna get my tea. What's my timer saying? Oh yeah, it's oh interesting. I'm almost in perfect sync with the Borg countdown. Okay, I'll be right back. Hmm. Okay. So before I start work looking at video stuff, um, let me uh have to reply to a message and then take a look at some other stuff. Actually, maybe before replying, I can do the change. So, okay, where are we? What's our status? What's our diff? I have the Windows fix me, and I have some changes in the server. Okay. Okay, what if I do this? Okay, so pressing the button should cause the tooltip to wiggle, but it just doesn't. Oh, actually, with this, we don't even get in the animation. That is interesting. So that defer the init was kind of important. Huh, that is curious. But doesn't that technically put us inside of the button? So yeah, that changed did nothing. So yeah, I still can't figure out how to wiggle it. Okay, so to do what are we looking into next? Next thing that I want to test is this. So I'm going to close this. Um, Actually, this was fine. So I'm gonna run a local server with echo on. Then I'm going to connect to it, join, test. Yeah, I hear myself back. Okay. It's not important that I hear myself back well. I just wanted to make sure that it worked. Now there is one thing that we removed from the server, which is batched sending of packets. I need to see if this now works or if it's still broken. So the way it works, I believe, is that normally we do batch plus one, and then in here, so let's see. As we loop, oh, I also want to change this. Man, this really sucks. This whole thing. So let's make this better. Const receiver UDP is client.udp, or else no, that's the wrong message. It's not same user. It's this. Um, continue. So with this, we can remove this and this, and then everything can come out a little bit. If not, options echo, and it's the same. Skip, and then oh shit! Why did I keep these both? I guess we can just get rid of this, and if this is it. Okay. So every loop, we put these new, as we loop, we put stuff in the batch plus one. If the batch is full, or if we're at the last iteration, we send many. Okay. This code is not 100% correct. There's still a bug in here, but it should be good enough. What I want to test is if this works in Zig, if this is working, or if there's a bug in Zig. Test. Yeah, it works. I can hear myself back. Okay. Next, I should test if this works also on Linux. That means deploying a Echo server, which we can do. The Echo, the target x86 for Linux fast Echo. There we go. Perfect. We already know that that's what we want. Can we SCP this file? Not like this. Okay. Test. Test. Okay. Yeah, I can hear myself back. So that works. Um, so we can build a non-echo version and deploy that, I guess. Although I might want to fix that bug first. So here's the bug. The bug is that we have a bunch of reasons to want to skip a given ID, and that might make us miss our last opportunity. So long story short, this like batched stuff needs to, here we need to flush the batch if it's full, but then there needs to be a second send many for whatever is still in the batch once we have finished the loop. So it needs to be something like this. So if the batch is full, flush. Then the for loop ends. Interestingly, we don't care about this index anymore. That's good. Then we get at the end and we say, if batch index is greater than 0, then we want to send again. And this time it doesn't matter that we reset the batch size. Okay, this should make it right. So let's build it right. Actually, maybe not release fast. What if it was not optimized at all? Oh, I should have put it in Linux fast. Just Linux. And then Linux fast should have this. Okay. So stop Awebo and send up Linux. Okay, connected, joined, perfect. Okay. I think this is good. Again, let me try locally one last time to listen to myself. Test, test. 1, 2, 3. Yeah. Okay. Okay. I think this alone is a commit. Okay. Next is in source main. We have this Windows stuff. I guess. Let me see if I can figure out the Zig issue number that is blocker for this day for this stuff. Ba-da-ba-ba-ba-bum. Okay. So this is done. Uh, I am curious about the network stuff. So, sorry, the network stuff for video. There were people in chat in the past that were pointing out how encoders have the ability to do like variable quality in a single stream. Then there's the topic of hardware versus software encoder decoder and stuff. So you know what? I think it's time to start asking questions to the clanker. Um, let's see what's the state of things on macOS. So I'm gonna do a macOS first development again because that's the machine that I have on hand. So I'm gonna start trying to make things nice on this platform, and then everybody whoever has other platforms that they use main that they daily drive, then they can work to make their own platform nice. Although you know what, that being said, I might be interested in taking a stab at this because I have a working um, Windows build of Awebo of the Awebo client that can make calls, but it doesn't do quality of service for UDP packets. Maybe that is something that we should introduce. So, hmm, hmm, let's see. Um, okay, let's start by looking at what we do have. So in webcam capture, we have a video device. We have a webcam capture manager. Discover devices and listen. Connected, disconnected. Start capture. Start capture with device ID. There we go. Start capture with device ID. Capture session preset. Video input. AV capture session. AV capture inputs currently added to the receiver. Clients can add capture inputs to a session by calling add input. Oh, interesting. Add input. Well, how do you add a input? What's an input? Maybe we can take a look at our own code for this. AV device input. Mm-hmm. Okay. Video setting KCVP. KCV. K stands for constant, maybe. CV pixel buffer format type key. BGRA. Hmm. Hmm. Okay, so in theory, we could ask the camera for other formats. Out of curiosity, what are the ones available? So, um, video settings, available video CV pixel format types. Oh, well, would you look at that? How do we loop over this guy? I don't remember how to loop over. How in Obj-C, how do you loop over a NS array? Block-based enumeration. Hmm. Okay, so it's more like for void item. In that, we do stuff. And then inside we do ns log. So the thing was saying ID. I don't think that helps. Does it? Doesn't this need to NS number? It's an NS number. Huh. Problem is that it is a number, but it's one of those guys. The NS array contains NS number star, and those values are, and those numbers are values in an enum. How do I print the enum case from the numeric value? Yeah. Oh my fucking god, dude. Come on. Don't have built-in string con. Uh, I think it's lying. I don't think this is true. Also, some of these are numbers. Oh Jesus. Hmm. Wait. If core video use derived enums for constants, enum colon OS type, else enum, and if. But does this thing have a name? There's no there. It ends here. It says enum, but it must have a name, doesn't it? Like, where's the name? Is OS type the name? No, that's not the name because it's used all elsewhere also. So this is a type def, and I'm fine with it. So no, it doesn't have a name as a group. It just says that it's an enum. Well, it's okay. I don't know. Let's paste some code. Let's see how this goes. So if I turn on Awebo, okay, so this is the camera on. Hello. Using camera HD program, null. I bet you that these nulls are the ones that we are printing. So this is not fucking working. Okay, this is now making me print all formats. Okay, so it's just me crappy stuff. And let's look at the old code. Oh, you know why this is probably not working? I don't know for sure, but these guys do have a macro that says use the right enums for constants. Let's see. Get the description of a pixel format from a provided OS type. But for this to work, it seems that this needs to be on. So do we need to set this on? Hmm. I'm not really super convinced, but we still print null. Also, we think that wait, actually not even sure that that null is ours. So let's make sure that we see that the null is ours. Okay. Yeah. So we have some values in there. And we have some values in there. We have a 32, and then we have a bunch of bigger values. Exception create with format type. So yeah, why is stuff not working? Description array create with all pixel format types. Description create with pixel format type. Allocator pixel format. The nullable allocator. What if we pass null? Definition get value pixel format name. I think I want format codec type. Still null. The heck? The thing is, I can't even read exactly what those are because it like also what does it mean that some of these are single quoted strings? Does it mean that their value is a pointer to those? Also, we got 32, right? So 32. 32 base 16 is what, 20? So we have a 0x20. No, we have. Oh no, wait. We do have 20. That's ARGB. I'm confused as to how some of these um are like these strings. Man, I guess what I can do is that if the number is bigger than what is it, 20? Well, 32. If the number if the number no 20, we got to 28. Well, I can say that if the number is bigger than 100, then we treat it as a pointer and we read 4 characters from it. We can try that. Also, it's an NS number. Char value. Mm, string value. Mm, I don't think this will produce what I think, what I would like for it to print. I don't think this is it, but who knows? Yeah, this is just it's basically string formatting. Makes sense. I think I want this, and I want to turn it into a char star. Point 4s. I don't know. This is probably a bad idea, but I really don't know. It's not a pointer. I Am I supposed to read it as a 34? I guess another way of looking at it is that those are all 32-bit values. How do you do it? Oh, but I would have also to mask. Um, the int value, I can take the pointer and cast the pointer to this thing to a char star. Oh, okay. I think we're getting there. There we go. We got it. So this is what the camera supports. Hmm. Okay, man, it took a while, but we did figure some stuff out. Then I guess the next question is, um, in macOS, I have, let's see. Wait a second. Where's the? Oh, this list is not complete. Wait, this guy we saw. This guy supports YUV2, which is not in here. There's this. That's technically YUV. Oh, maybe that's on me. Maybe I'm messing up the endianness. Yeah, this is BGRA. So this is 420F and 420V, and then US. 420V. No. Oh yeah. Huh. Interesting. Okay. Uh okay, so we have a capture session. Okay, let's see. Temporal SVC via video toolbox. Best native option. VT compression session. Okay. Capture session, whatever. Oh, we're back to wait. PT compression session ref. Picks a buffer format type key. And then it picks another thing, not the one that we have. Setup compression session. Let's see. You could see what other codecs it supports. Scalable high profile enables temporal plus spatial SVC layers. Enable SVC temporal scalability, multiple temporal layers. Number of temporal SVC layers. T0, T1, T2. Number of layers 3, compression section. Okay. Base layer ID, compression section, property key, base layer, frame rate fraction. Base layer is 25% of the full frame rate. So let's assume that we have normally, so this is for webcam. So let's say that we keep the webcam at 24 frames. I mean, 24 or 25. You know what? We might be, let's add a sprinkle of Europeanness to it. Let's do it 25 frames. So if it is 25 frames per second, then 1/4 of it, that's annoying to calculate. Okay, let's imagine it's 24. Let's make it easier. Half is 12, half is 6. So 6 keyframes per second. I guess that would be perfectly reasonable. So rate control, average bit rate across all SVC layers combined. Their rate limits 2 megabytes over a 1 second window. GOP? What's a GOP? Compression session property max keyframe interval. Keyframe at least every 60 frames. Were we not? Well, I guess the base layer is not necessarily only keyframes. I see. Oh, I get it. Max keyframe interval 60. Max keyframe interval duration 2.0. What does that really mean? But okay. Key real time. Allow frame reordering. False. Low latency. No B frames. Finalize encoder configuration. I think 3 temporal layers is to match. Huh. Anyway, we get the image buffer. Force keyframe every 300 frames as a safety net. Okay, this is the third place where we're touching keyframes in a way that makes not a lot of sense. And then we do session encode frame. Okay, and then once we have the encoded frame, to do packetize NL use strip 4 byte length prefix, add 001 star code and send over RTP, write to file, pass to decoder. Okay, so I guess it could have been worse. I wonder what other things are supported and if they're. I'm really curious to see what other codecs are supported by this guy. So this is Video Toolbox. I mean, I think that it is safe to say that we want Video Toolbox. And then we can take a look at this guy. Compression properties, compression session, compression properties. Let's see. Codec type. No mention of codec type. Video encoder list. Codec type. Okay. Builds a list of available video encoders. Let's try to use this code and let's print what's available on my machine, for example. I'm curious. So let's see. VT copy video encoder list. Um, show me code to print. Okay, let's see. Mm. So video toolbox is not enough. Oh, I need to add also AV Foundation and Video Toolbox. AV Foundation I think I already have, but I don't have Video Toolbox. See how we do now. I still don't have VT copy video encoder list. What do I have in here? VT copy video encoder list. It's here. What do you mean? What's core media? Do I have core media? I don't have core media. Maybe there's that. I don't know. Okay, VT copy video encoder list. That is 100% correct. Oh, it's the decoder list. That's problematic. Video decoder list. Okay, so that one doesn't work. And yet, so we have here we have video encoder list. Yeah, where's video decoder list? Okay, so the decoder stuff is fake. So thank you, Claude. Okay, let's see what we have. Available video encoders. Apple 24-bit RGB. ARGB. Apple ProRes. ProRes HW. Apple Depth HEVC. So that should be H.265, but what does depth and disparity mean? Impossible to know. So there we go. We have H.264, software and hardware. Then we have H.265, hardware and software. JPEG, hardware. Apple Muxt Alpha, Apple HEVC. So H265 plus Alpha, hardware and software. Okay. So this machine can do H264 and H265. In hardware, I mean. Of the ones that we care about. Okay. Okay. Well, at this point, it's not that important. Okay. So, with this, we know how to discover which codecs are present. I guess the next step would be to just set up the compression pipeline. And then after that, we just need to send the video over to the server. Yeah. Well, most precisely, I guess we want to have the callback compress the video and then put it on some kind of channel, essentially. Yeah. Although, should this be a proper channel with mutexes or should it be something with atomics? I think it needs to be a ring buffer with atomics. Hmm. Okay. Okay, I think I'm gonna get some tea and then I'm gonna add the compression stuff in here. Okay, let me go get tea. I'm back. I was annoyed with Discord. I was struggling with updates when I thought I should vibe in Twitch a bit. What I see OSS Discord alternative in Zig. Yep. Hello, Yushman. It's a long walk to reach feature parity with Discord. But it is possible. Okay, so we were talking about adding compressor state and then and then we are gonna have to copy the rest of the boilerplate, I guess. So we want a there's a video data output. Did we have a video data output already? Yes, we do. Okay. And apparently we need these guys. Also, I'm confused by this syntax. Implementation interface. Wait, an implementation can have state? These don't need to be properties? Ah, man, whatever. Oh, that's a ref, so that also uh okay. So when we do init, initialize the manager, set the capture. That's all well and good. Set up compression session. Might as well copy. No, I don't want to copy it all because I just want to copy what I want, which is this. From connection, lead capture. AV capture connection. Okay. There it is. Encoded frame callback. Copy. I'm actually really curious. I want to try this stuff out now. Okay, let's see how it goes. Setup compression session, we were saying. Encoded frame callback is our output callback. Why do we need to do this? I guess it's because of a necessary typecast. Like, why can't we just do this? There you go. I mean, we'll see if it has complaints. NS assert, interesting. Let's see. Scalable high profile enables temporal plus spatial SVC layers. Each layer builds on the previous. Receivers can drop higher levels. CABAC, CABAC, better compression for SVC. Who knows? CABAC, CABLC. Let's see. The entropy encoding mode for H.264 compression. If supported by encoder, this property controls whether the encoder should use context-based adaptive variable length coding or content-based adaptive binary arithmetic coding. CABAC generally gives better compression at the expense of higher computational overhead. The default value is encoder specific and may change depending on the encoder settings. Care should be taken when using this property. Changes may result in a configuration which is not compatible with a requested profile or level. Results in this case are undefined or could include encode errors or who knows. Okay. Number of temporal SVC layers. We said 3 layers. 3 layers. Okay, so the question is, okay, temporal layers are basically the ability for, hey Soap, electron bindings. So temporal layers are basically the mechanism that allows us to basically drop some packets, or rather not send some clients some packets and allow them to see the video at a lower frame rate. With 3 layers, it means that there's going to be, let's say, like the option to do 15, 30, and 60 frames per second. Whether that's actually true, the 3 numbers that I just said, depends on the configuration and whether that's possible or not. I don't know. I have to look into it more. But that's the general idea. So the question is, what utility do we have for this? Frankly, I'm not sure. Like, we're talking about webcam in this case specifically. So I don't think we have a reason to do webcam at any frame rate other than 24 or 25. And so when you receive the video from a temporal perspective, yeah, like I really don't see a reason why we would want to do webcam, like 60 frame per second webcam, for example. We could, but why? Personally, based on my experience, I believe that 24, 25 is the right number. Higher, I don't know. Higher just doesn't feel right. So let me see what we do with the normal config here. What do we request for FPS normally? Oh, we just call start capture and then we see what it says. Well, apparently it turns out that the FPS depends on what the device can do, I guess, understandably. We could set up frame rate conversion, but I think the frame rate conversion is kind of inherently crappy. Webcam start capture. What do we pass down? 30. Okay, right now we're passing 30. 30, I guess, is also fine. So why would somebody want 15? I don't think there's a reason for you to want 15. I think that's what we should keep. And here, the temporal stuff, I think we should just turn off. Otherwise, yeah, I don't know what else otherwise. I think this should be turned off. Multiple resolution, I think, is definitely more interesting for webcam. Oh, by running parallel VT compression sessions at multiple resolutions from the same capture source, each layer is independently decodable, which satisfies special scalability requirements of streaming compressing use cases. Here's the full implementation. This is so crappy. So it means that this thing does support temporal, but it doesn't support spatial. Um, Pivoted toward direct Objective C implementation approach, and here's the anus twitching, Claude's anus twitching as it produces poop. Uh, I guess what we could do is just set this to 1. Compression real time. I don't know what's frame reordering. So there's a scaling to lower resolution and then compression, then less banana, and then higher quality. I guess that's kind of what we would like, just everything bumped up by a notch. Like we would want the lowest probably to be 640, then 720 maybe. No, I think we would want maybe just 720 and 1080. Um, well, so you could have the other person full screen. That you want at 1080. And then if instead you have like just tiny webcams, I think in that case, yeah, you want that to be 720 because if this is 1080, 720 is one quarter of that window. And you might have, you will have the window slightly smaller than one quarter, but it's not going to be one quarter of that. Maybe it might. One quarter of a quarter. This big? Yeah, no, you will have the window that size sometimes. So probably that's kind of what we want. One quarter pixel count. No, but I'm talking about I'm not talking about pixel count. I'm talking about screen occupation. Okay, let's double check if my understanding is correct. Can we agree that when you have a 1080p window and then you have a 1080p window and then you have a 720p window, the 720p window is one quarter of the 1080p window, right? Nope. It should be though. Isn't it half on either dimension? No, it's not. 1080 is 920 per 1080. And then it becomes 1280 times 720. 720, 1080. 720 is not half 1080. No, you're right. So 720 is not half of 1080p. Right. What's the relationship then? Like the ratio? 2/3? 2/3. Okay. And this guy went bonkers with the code here. Oh wait, this is just one file. Oh, we gained 3 files. Hmm. Okay, you know what? Considering that SVC is not a thing, let's um let's ignore SVC. Hello, Diablo. 480p. 480p is what is it? 640 by 480. Oh, 854. Oh, right. You know what? That's a resolution that I've never seen in 16 by 9. That's a resolution that I've only experienced in 4/3. Hmm. But if I remember correctly, bit rate wise, 720p doesn't let you go that much lower than 1080p. So you're saying that if we were to have a 720p stream, that would be almost as expensive as having two full resolution streams. I think that the target that I would like to optimize for, um, what I would like to optimize for is somebody having a 2K monitor. So the expectation is you have a 2K monitor. What would be the setup that makes the most sense? So the assumption is you have a 2K monitor. Webcams can output at best 1080p. If a webcam can do better than 1080p, I would say that for now we don't care. Maybe that's a thing that we can worry about in the future, but for now let's just assume that 1080p is the pinnacle. Then alt streams being 720p for one focused plus two smaller. Okay, so you're saying 720, not lower than 720. Hmm. Yeah, because we could okay, by the way, I'm not an expert, but um my imprecise understanding is that we can decide how much bit rate to give to the 720p stream, right? So we could just um set a low bit rate and that's it. 720 seems a little bit big though. I mean, if you have for example, this is a 2K monitor. The one that you're looking at right now is a 2K monitor. You don't see a 2K stream because of fucking Twitch, but so this would be, let's imagine that this is a 1080p window. Actually, this might very let's make it a 1080p window. Um that's it, right? Please don't bitch about, god damn it. Okay, that would be 1080p. Um that's big. On a 2K monitor that is still pretty big. I think that we can go lower than 720. I think 1/4 of this would be already plenty good for smaller cameras. Keep in mind, unless you offer a full screen video mode, your target video window isn't 1080p. Um, if you mean whether I allow to have to focus only on one other color, yeah, the answer is that I want to offer this. I want to give you the ability to do full screen with the other person, like literal OS level full screen. And also, I want you to be able to focus primarily on somebody's webcam and then have everybody be smaller. Yeah. So, I think that what we want is uh, big focused and then many small people. I think two is enough. But I think that the secondary ones shouldn't be 720. I think they should be smaller. The one thing I'm missing from Discord is good multi-view support. Wait, you're missing when using what? Because Awebo doesn't have shit, so you would be missing the whole feature. Are you talking about other tools that you're using? Jitsi has some support for um, what you call multi-view. Well, what I think you are calling multi-view. Although, yeah, it has support for it. I wouldn't say that it has good support for it. Yeah, I think 1/4 is. So we were saying it's 580p, half of 1080p, 540p, 540. Oh, sorry, it's the other way. Wait, you're missing from Discord is good multi-view support. When watching multiple friends stream stuff, it's tough to fit everything in a 1080p screen because of UI wasting screen space. Right. Yeah, that is a good question. Although that is screen share, so right now I'm concerning myself with webcam and not screen share. So that's also another interesting question. For screen share, I think it doesn't make any sense to produce multiple quality streams. I think screen share should be, maybe it makes sense to have to do temporal SVC for 30 frames per second versus 60, but that's it. Unless somebody's doing show and tell through the webcam. Yeah, I would consider that a non-supported use case, at least for now, because yeah. Okay, so 1080 plus 540p. Hmm. Yeah. Yeah, to be fair, I am restricting myself to a very uh yeah, I'm restricting myself to a very narrow slice of my 1080p window, and it's still good enough. Hmm. That being said, I think I guess what we want is that I think a reasonable way of splitting it is this: 1080p. If you're doing one-on-one 1080p, let's assume that you do even full screen. Then, if there's 3 people in a call, you will want to see 2 faces, one next to the other. Um, I think at that point, probably the best resolution would be 720p, but but I don't think we should ask the people who are sending the video to send 2 streams. I think what we should do is that you keep receiving you receive 2 1080p streams and you downscale them to 720. Then when we have 4 people in a conversation, so the moment that you start having 3 people, 3 streams that you watch, I think at that point we should drop down to 540. So we could drop down to 540. Although, you know what would be funny? To have more granularity, like we keep the granularity, maybe something even smaller than 540. Um, and basically, what we could do is the compression stream doesn't run unless somebody is requesting it. So you basically communicate to the server which stream you want for each one of the other participants. And that way, like if you ask for the other participant to send you a 1080 stream because you're zooming in on them, then they send it to you. But then if you don't do that, if you're only looking at the grid with a bunch of people in it, and nobody's watching that one person in 1080p, then like the server tells them to not send the 1080p stream in a sense, essentially. That could be cool. The downside is that means that whenever you switch layout, there's going to be a delay before you can watch. But I mean, we can still show the lower quality stream just blown up in the meantime, and then when the new stuff comes in, we show the new one. Huh. These are interesting things. So here's what I will say. Let's just get it working for one thing. Let's get one stream working, no SVC whatsoever. Let's see what it takes. And then we can add as an enhancement all the resolution transitions. Also, I would say this. The fact that these encoders don't support SVC really fucking sucks. Because if it did support SVC, then we could actually set up the layers the exact way that we want, and it would work fine. We would be able to set up that the basic stream is 540p, and then we can do 540, 720, 1080. Like we could do the essentially the granularity that we want with, and that would be essentially almost without delay. Or, well, it would be lower delay than the alternative where you have to ask the client to switch from doing one thing to another. Hmm. Man, 1080p is big on a 2K stream, on a 2K monitor. I thought it would be smaller. I have a 4K monitor and another monitor, the one on this side. And yeah, that on that monitor, 1080p is much smaller. It's 1/4 of the screen. I definitely got it wrong in the beginning. Just how 1080p, 720p is big on a 1080p screen. Yeah, fair. Okay, this all makes sense to me. That was a good discussion. Thank you. By the way, Diablo, if you're still around, I believe you were opinionated, like you were very opinionated about H.265 versus AV1. I was shopping around for trying to see what's the state of things with AV1. I'm seeing that there's no, so AV1 you have to have a software encoder and decoder. I saw that AV2 apparently is in the process of being standardized. Then earlier today, I looked at which encoders I have on this machine, and let me scroll through my crimes so that we can see. Eh. So I was looking at what I have available on my machine, and well, relevant to us is essentially this. So I have H.264 hardware and H.265 hardware. I also noticed that I entered a channel in Discord and I turned on screen share and I saw the Discord was sending H.265. So Discord is doing H.265. I mean, it does make sense. Like if we support H.265 hardware, then we should do H.265 hardware. And if we support H.264 hardware, we should do H.264 hardware unless we support H.265 hardware. Yeah, the only thing is that it sucks that we cannot do proper SVC where one stream has all the resolutions in it. But at least we can do it with frames for screen share, I guess. Although I would be curious also. So one thing that I would like to support. So Jan was mentioning that there is a setting somewhere in Discord to do high resolution streaming for where you do super low frame rate, but show advanced stream settings. Let's see. Stream attenuation automatically reduces stream volume when people are talking. Oh, that is new. Use our advanced technology to capture your screen. Our signed DLL is injected into the application to capture frames. Oh no. For screen sharing, resolution matters so much more than frame rate. That's not true. It depends on what it is that you're uh what it is that you are screen sharing. I mean, software development, absolutely, you are absolutely right. But if I'm streaming, I don't know, like Call of Duty, then yeah, advanced show diagnostic settings, streaming for overlay, diagnostic audio recording. Okay. Gaming, smoother video, or unlock HD at 60 frames, but I need to get Nitro. Never mind. Screen share, clearer text source, 5 frames per second. Custom. Huh. So what do they do for that setting? I guess they keep the bitrate the same, and then because you have much lower FPS, all the bitrate is spent on quality in a sense. Yeah, it's 5. It's 5. At least for me, without Nitro, it is 5. Yeah, but it's not just lower frames. I think it's meant to give you extra clarity. So I guess it's essentially the same bitrate as the other one. Okay, so I don't know. Let's make it happen. Let's see what happens. Let us see what happens. Do. Okay. I'll be right back, and then very quick bathroom break, and then I'm gonna start coding this stuff, and let's see how big these packets end up being. Here's another thing. Um, we are not. We never had to come up with the concept of packet fragmentation um, yet, because all our Opus packets are so small that they all fit a UDP packet. But I'm guessing now we'll have to worry about this stuff more. So I'll be right back. I'm back. Do-do-doom. Okay. Let's see what our friend here suggests. AV asset writer. To file. Oh my god. I really like this asset writer thing. No, we don't want to use this. We want to use VT compression. Yeah. Okay. Let's see. Let's see how this goes. It's available codec. Let's see. Check for H265 hardware decoder first. If available Mac 1013. Oh man, I guess we can remove the if. That prints the okay. Oh man, what a silly thing. Okay, so this is fine. Mm, why does it do this? Best available codec. Okay, let's take a look. Hardware available. No. Status. VT copy supported property dictionary for encoder. 1920 1080p. Yeah. Directly pro hardware availability. Is hardware decode supported? Then why is this the encoder list? For an codec type source for CC as a number. H265 encoder found. But even if it's found, I mean, We don't need all of these. What is this? What is this clanker doing? That's it. Wait a second. There's this status VT copy supported property dictionary for encoder. Wait a second. What is this code? This is what is this delirium? HW available is not used anywhere. Why do I always get this stupid as fuck output? But I think this is the right one. Like you just ask for this. This call returning true does not guarantee that that hardware decode resources will be available at all times. Huh. That is an interesting point. But this other check means nothing. So none of these properties are like saved. The rest of the stuff is just garbage. Okay, this seems all garbage to me. I'm gonna nuke all this stuff. Oops. Okay, so we have this beautiful function. I already have all this set up. This is asking frames in a very specific format. We'll see about that. Set up compression session. Eight megabytes. Okay, you need to stop putting emojis in my fucking print lines, man. Like, it's just not cool. So, let's see. Start compression session. Hmm. Oh, this also has a return value, which we're not checking. Oh, well. Okay, let's see. Encoded frame callback. Encode error is keyframe. Attachments not sync. Is keyframe equals not sync equals null, or cf boolean get value not sync. Huh. Consume encoded data here. Write to files in our network, max into container, etc. Get data buffer, total length 0, data pointer, buffer get data pointer, size dot bytes, blah blah blah. Okay. Well, printing this is already good enough, I think. Okay, so when we get the frame, okay. Um, so in the sound encoding, we need set up compression session. Oh, this guy went insane again. This underscore compression session does not exist as a variable. Unless it's another way of referring to properties. Somehow I doubt it though. But it's not, I'm not getting complaints. That is so weird. Maybe this is a way of referencing these guys for real. Huh. Okay. Okay, the last thing that we're missing is what we do in the temperature callback. Let's see. Process video frame, CV buffer pixel retainer. This is getting an image buffer. Okay, it's the same thing. No, it's not. I guess it kind of is the same thing, considering. Wait a second. I guess these guys are aliases of one another. Yes. Okay. The fuck. PTS duration. Okay. Wait, I deleted something I should not have deleted. Okay. So with this, in theory, we should have wired in compression. So we should get here. We should get to the point where it starts printing this. Bro, please, enough with the emojis. Okay, let's see how far we get with this. Oh, there was another instance open. Okay, so I don't expect this to work because um, the format that we requested is probably not compatible with what the encoder does. But I don't know. Let's see what happens. Never fucking mind. It works. Boy, are these frames big. Holy shit. These frames are gigantic. Well, look, I'm on a diet. I'm very thin. Um, these frames are big. Very big. I think we need to lower. So we need to lower stuff. Yes, this is fine. I think 8 megabyte as the frame rate is way too much. Can I see how it goes now? So let's see. Using encoder H265. 6,000 bytes. 24,000 bytes. 8,000 bytes. 16,000 bytes. 22,000 bytes. That is a lot. Keyframe encoded. Jesus, 115K. That is a lot. That is a lot. So if we use these for our packets, whew, whew. Well, sorry. In any case, we need to fragment this data because um, we can already see that it doesn't fit a we can already see that it doesn't fit a 64 kilobyte UDP packet. So no matter what, we have to split this stuff up. We need to complicate the protocol. Hmm. So, well, I guess the next step is Well, I guess we need to go to the protocol and we need to start thinking about how to make this work. So we can't just have packet sequence number and restart ID. We need to, well, this is for audio, essentially. Yeah, I think it's time I define my packets in a better way. Like my header cannot be this. My header needs to be something better. So sequence number and restart ID are a concept that only exists for audio. For video, there's no restart ID. Mm, for video, there is no restart ID, but there is a like chunk ID essentially. Like chunk, basically, I guess we could do 2 bytes of chunk number and then chunk max. So that you know which packets you need to collect. And this is not 12. So I think the number was different. It's not 1260 even. It's like something like this, 1252, something like that. That is not a lot. Man, that is really not a lot. That means that a keyframe takes 100 packets. Holy shit, we are bumping up the requirements of what we are doing by a lot. Jesus. For 1080p cameras. I'm starting to think that maybe 720p cameras is fine. Oh well. The problem is that, so everybody keeps saying that we should not let the network do the splitting because they're not gonna do the splitting for us. But the problem is that if we don't do that, then I mean, there's gonna be a ton of overhead. Basically, every packet we're losing 28, 32. We're losing 40 bytes everything. I mean, 40 bytes means that every time we send 100 kilobytes, every 100 kilobytes, 4 kilobytes are wasted on overhead. Hmm. Hmm. Oh well. Okay, so let's I think it's time to actually formalize our packets a little bit better now. And they're attached to all UDP messages. What's in there? I think that for now the only thing that we really have on every message Oh, I see why the packet sequence number was set first, because that way the ID equals 0 has a special meaning. It's open stream. For video, well, we don't need that for video and other things. I mean, that thing will need to have sequence number, yes. Um, yeah, but in any case, this is not specified. This is just data like this. I need to double check this number. So the start is not part of the header, just sequence. So that means that that's gonna be 448. Oh, that means that we cannot grab restart out of this header. Oh, that's gonna have to change some stuff. But also, how do we know what kind of packet we're looking at? We need to be able to look at the kind of packet. So we need to waste some bits on this. So packet is gonna be, you know what? I think it's time that we do this. I think it's time that we properly formalize the concept of multiple streams, the concept of full blown client IDs. I think it should be 64 bits of this, like client ID, and then stream cannot be just 1 bit. Stream needs to be more than this, because S was essentially um, S I think was like 0 for microphone, 1 for, actually I don't know what the other thing was supposed to be. Yeah, I think we need to stop to be being this stingy. I think this needs to be all client ID, or rather, this should be the stream ID. Which should be a client ID plus, this should be like this: client ID, 32 bits of client ID, let's assume I have, I think I had some of that logic in here. Let's see. U26 for user IDs, maximum 67 million users per server. That's a limitation, but that would be fine. U4, max 16 clients connected. U2, max 4 media streams, camera, voice, screen share audio. I think we have a reason to at least add another one to this list. So if we add another one to this list, that would bump us to 8 media streams unless screen share and screen share audio we consider one stream. I think we should. I think screen share and screen share audio should be one stream. You know what? Maybe this is fine for now. So that means U32 total. Okay, let's assume that this is the case. And so then this is client ID. That means that then we want to have a oh, actually this would all be U32. This would be a full stream ID. So this would be user ID, client ID, and then media streams. Oof. Okay, let's imagine that this is really the case. So U26. Like here. Hello, Marquis. We said user ID 26, 4 bits client ID. Like this. Oh, wait. This stops at 25 because it's 0, 25 to be 26. That leaves 4 bytes. And then finally 2 bytes like this. So that would be user ID, client ID, stream ID, yeah, I like this a lot. This is really good for from a media perspective. That is really good for a media perspective. Okay. So let's start reshipping this. U26, then CID U4, or rather, let's call it seed. It's not the full client ID because the full client ID should be this. This is the full client ID. Extern structs cannot contain U26. Yeah, no problem, dude. We're going packed. It's packed time. Oh man, this is okay. This is gonna be an adventure. Holy shit. Size of, yeah. Okay, so I guess we can leave it unspecified as this. As is. So user ID, client ID, stream ID. U2. We can make it an enum. Voice. Camera. Screen share. Oh, well, screen. Third one, I don't know. Um, so originally I was saying screen audio. Could do that, but I don't know. Reserved. I guess we can call it stream type. And then sequence number. Hmm. Sequence number. Sequence number. Let's assume that this stays in the header. Okay, so this is our header. Oh, that's how I was doing it. That's actually not a bad idea. Ooh, that is actually not a bad idea. So we don't go packed, we stay extern. And then we say ID U32. And then in here, we do it like this. That is nice. stream ID. ID.client ID. Well, I mean, this is a stream ID. This is essentially a stream ID. Would this work? Can you put a pack struct in an extra struct? Oh, look at this. This is wrong now. Right. You're 32. I guess you can do this. Okay. So this seems nice. So client ID. This function doesn't exist anymore because there's no point in it. Okay. Kind media open stream. Nah, we need to make more sophisticated. Let's see, open stream request. I think an open stream request should essentially be like this. Oh wait, nonce. Oh, never mind. But we don't need to have the restart ID anymore because this is not part of the header. TCP client ID. And there's no reason to do this anymore because if you have this, this is a client ID shift by 1, actually shift by 2. This is 2 bytes. So that means that if we do this, this is not necessary. We know who you are. So it's only the nonce at that point. This is kind of making me want to put the, you know what? I think this value should be up above. I think the stream ID should be the first 2 bytes. That way we can mask this number. We don't need to shift it. Although, whatever. Yeah, I think this is how this should be shaped. So this is an OpenStream request. The packet must not contain any other data. Yes. Um, there's serialize and parse. Client ID equals 0. So I'm not using this function. I cannot be using this function because this wouldn't work. The heck? Yeah. Oh no, it's because right. It's because we don't know our user ID with the current system, but we will. Yeah. So I think the new system must work under a very different idea. Hmm. What's a nice way of doing this? I guess this is the most straightforward way. I wouldn't know how to do this otherwise. I guess. So that means that now we need to formalize um voice packet and like camera packet, that kind of stuff. So what are our screen types? Voice, camera, screen. So what's a voice packet? Let's make one. Okay, what's in voice? Voice needs to have um, the restart number, for I'm gonna write 58, 56, whatever. I don't know if this number is correct, but in any case, 250 bytes, actually even less. It's like 200 bytes. Okay. This contains a restart sequence number and then data. Do you need a length for the data? No, because when you read a UDP packet, um, UDP is not stream based like a TCP. UDP is datagram based. So one datagram, one packet knows its own length. So essentially, the network carries that information for me. Or let me put it another way. In here, in the UDP header, this is where the length of the entire packet is already stored. So the network knows this already. I don't need to have this on my end. So I don't know about serialize. Well, this should look different in any case. So this should be more like client ID, restart, sequence, restart, data, I guess, something like this. And then maybe GPA should go first. So stream ID. There we go. Yeah, actually, why do we have this? I mean, why do I do this? Because on the other side, I'm already, I think, you know what? Let's not add extra shit that we don't need. Although these guys might be useful. I mean, they don't do much, but they might be useful. Let me think about it for a second. The The only problem is that this interface, as I'm writing it, it forces heap allocation, and we might not want to do that. We might not want to do that. So um, I guess passing in a buffer should be what you do. Like a better interface should be out. Question about the GPA. Is there a convention in Zig about whether it is the first or last parameter? Yes, there is. It should be the first. The order should be this. You're making a function. Again, it's a convention. So if you, for some reason, want to do things differently, it's fine. Nobody's going to crucify you for it. But normally, when you're making like a function, IO goes first, then GPA, or, arena, if you want an arena style allocator. Or more precisely, if you don't plan to do precise tracking of resources that you allocate and you expect the caller to kind of free everything all at once, so either arena or GPA, and then everything else. And obviously, if your foo is a namespace function inside of a struct, then the quote unquote self parameter, so in my case, let's see, it would be voice, that must go first. So it's the self parameter first if it's a namespace function, and then IO, GPA, and then everything else. Now, I think there is one situation in the standard library where Andrew breaks this convention. Error details like diagnostics. I would say, personally, I would put them right after the allocator, but at that point, it's, I would say, entirely up to you. See this question right here. Do you ever see a real, natural, organic human being person using OpenClaw, etc. unironically? I don't know, man. I don't use that shit. So we do it like this. So let's see. Stream. This is the header, then const voice. Uh, so like this. I wish there was a way of saying that there's like trailing data so that we could put it everything in here, but uh, never mind. Bytes to value voice? No, we can't do this. There we go. So this would be correct parsing. Okay, so now I have formalized a voice packet. So the next would be formalizing a camera packet. So camera doesn't have restarts. Camera should have something that tells you if it's a keyframe, probably. So it should have a yeah. Where do we grab that information? Huh. Mean. So we could steal one bit from the sequence number to say if something is a keyframe or not. The problem is that we cannot steal the most. We cannot steal these. Stealing another. We could try to steal the very last. This one. Huh. It because it's just one beat, right? The key, the keyframe thing, it's just one beat. Although, although there is another problem, which is clients should be informed of stuff like resolution and format. Is, for example, is this H.264 or is this H.265? Uh, huh. At the same time, should this information be repeated per packet? I don't think it should. Are you feeling like automatically allocator slash IO would be passed in a consolidated struct or as separate arguments in the future? Um, there is no one answer to this question. You can do it however you want. I would say that your starting point should be just to pass them around as individual arguments, but there are plenty of cases where it would make sense to keep them in structs. I do that myself. I pass them around as arguments occasionally. And in other cases, I have, for example, the the client core implementation keeps a reference to a GPA and an IO. Actually, let me swap them around. There we go. This guy keeps track of an IO and an allocator. And then in my GUIs, for example, let's say in channel list, whenever I'm rendering the GUI, I pass around core. And I occasionally will pluck a GPA out of core. So this is it's a non-problem. It's it is not a thing where it matters much what's idiomatic or not, or what the ecosystem does. This is entirely up to what you're doing. Okay, so keyframes. Do we just waste one bit for a keyframe? Do we really waste one bit? I mean, we have to waste one byte at least for it. It seems weird to me to not use at least one byte. I don't know what other information could be there for. I guess you know what, we need to start with something, and then we'll try to make it better afterwards, I guess. So maybe what we can do for now, um, also what I'm thinking alternatively. Nah, never mind. You know what? For now, let's not do this and just let's see what happens. So that means the camera is empty. It just has data. No. Okay, let's give it something. So let's say that we have this. It's 4 bytes, and it's 4 bytes of keyframe. It's wasteful, but I don't know. Absolutely wasteful, but okay, there you go. Oh no, wait. Wait a second. This is the whole reason when we're doing this work. This guy needs more stuff. It needs information about um chunks. We need to split these guys necessarily. Oh man, how many splits? So we had a 100k frame. Hello there, Teufel. um a 100k frame. By the way, I'm starting to think that maybe this should not be just camera. This might be like video, and then camera and screen share the same packet format. They just specify a different stream type. Yeah, you know what, let's not call it camera, let's call it video. Okay, so video has, oof, okay, this is gonna be more complicated. So how many chunks are we gonna need? Um, so we had a 100k frame. Do we still have this visible? Yeah. So our biggest thing was 100k. And that is a lot. So that is a lot, but it is about 100 1 kilobyte packets. So, for example, we could do a single byte. A single byte would allow us to get up to 255 packets, 255 chunks, 255 chunks times 1250. Let's do the math. That means that one frame can be up to 300k. Um, that is not a lot. I think we might need more than this. When I originally set this to 8 megabyte, we were getting pretty chunky numbers. Let's take a look. Oh shit! I broke everything. Um, Right, we're breaking everything in protocol. Oh shit, let's undo temporarily all the work. Now, you know what? Wait, let me redo this. And let me save this file as a copy. Actually, no, 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 it's okay. We undo, but we make a copy of our changes. So these are our changes. I could have git stashed, but no, because that would take out other stuff. Okay, so we have everything in here. Cool. So undo everything, start the client. Mm-mm-mm. There we go. Okay, let's see. Yeah, now all the tiny frames are 50K, something, something. And then I got a 1600. Okay, it's not too bad. We could spare. It's unfortunate that by not allowing, like by allowing a fixed size to our UDP packet, we are essentially wasting also bytes in the header. That sucks. That really sucks. That does indeed really suck. Hmm. We can spare 2 bytes. 2 bytes is a lot. That's the max value. 65K. So 65K times 1250. Bytes to MB. Okay, so if we use 2 bytes, then we can support up to 81 megabytes worth of packets. That is a lot. Probably too much. Uh, we could do 15. We could do 2 bytes. 1 byte, 1 bit goes to whether it's a keyframe or not. I think that is fine. No, you know also what we need? We need the timestamp. I think that unfortunately this guy will also really kind of requires a timestamp. What's the size of those timestamps? Um, The timestamp might be in the encoded data. Let's ask the clanker. Let's see if it knows or if it lies to me. Okay, so I think I should assume that I will need also to pass around a timestamp. Um, let's see how big is a timestamp. Although I guess the timestamp could be expressed as a delta, maybe. Hmm. You know what? I don't know. We'll cross the bridge once we get there, I guess. Okay, so two bytes seems good enough, and we can steal 1 bit from it. So this is gonna be unused, and then sorry, what is it? Right in the middle. What is it? X15, right? Yeah. So where do we put the bit? The keyframe bit. Hmm. So if we put it in the least significant bit, that means that we always need to shift. Otherwise, it means that we need to mask. I guess we can shift. I don't know. For now, I really don't have an opinion. What is this individual bit? It's key. But it's keyframe or not. And then this is the chunk ID. Like this. Technically, we could move this up here, not have unused bits, and then just have more bits for data. So like this goes here. Like, I don't know if this is nice or not. This might be a bit unorthodox, but why not? Fuck it. So this is gonna be chunk ID and okay. Um, What's the K? If it's a keyframe or not. If it is a keyframe. Hmm. Yeah, it's a single bit field. How do we express this stuff? Can we do packed instead of extern? If we do packed, then I can do directly chunk U15 and then keyframe bool. Okay, that's one way of doing it, I guess. If there is timing information that we need to supply, I think that's going to be an opportunity to use the remaining 2 bits for 2 bytes for something, I guess. But for now, this is going to be 58. I think I should really decide what the MTU is, and then go by that. In any case, this is kind of going to be it. Chunk, keyframe. Okay. Fixed size packet or keeping the data length somewhere. That's funny. That's the same question that was asked earlier. It's UDP. It's datagram based. It's not a stream, so this contains length information. Like it's part of the UDP header. Okay. So with this, we should have it. Now I broke everything with this change because we have a bunch of code that now video Awebo channel's voice. Oh, this was renamed to. Oh shit. Oh. Okay, let's make this new code compile. I like how I structured it. This is nice. We just need to make it we just need to make everything compile, and then we're gonna need to have logic for um collecting video chunks, I guess. Yep. I think there's a problem though with this approach, because with chunk ID, I was thinking something like we don't know when it's the final chunk. Um, Maybe we need to steal a second bit that says that this was the final chunk or the first chunk. I think the way I like it is that we start with a high number and then we go down, and 0 is the final chunk. But then if we do it, then we know when the last chunk of a sequence of packets, well, of a sequence of chunks comprises one packet. But then we don't know what the starting point is. If there was no packet loss, we would know, because we start with 5, and then it goes 5, 4, 3, 2, 1, 0, 4, 3, 2, 1, 0, 5, 4, 3, 2, 1, 0, etc. But um, well, we don't know if the actual sequence was 6, 5, 4, 3, 2, 1, 0. We might have just lost 6, and so uh, then we're not doing great. So that means that we need a second bit. So it cannot be U16, 15. It needs to be U14. I think that is fine. Okay, so instead we do it 14. That limits to 20 megabytes the size of a frame. That is fine. So we steal another bit. Then we say whether it's the first of a chunk. First. The problem with first of chunk is that if we lose that, no, it's still fine. Hmm. I guess the alternative could be to use the other 2 bytes to tell us chunk number, chunk num, and other than chunk ID. Hmm. I'm trying to think how the request to resend packets would have to look like if we were to go down this path. So you miss, there's a hole. You saw 5, then 3. You didn't see 4, so you request 4 again. Um, so you request 4 again, but and that is fine. You saw 7, then you saw 4, so then you know that you need 6 and 5. If you didn't see the first packet, then you need to say, I saw, I don't know, 8, but it wasn't the first packet. So you have to say, give me everything before 8 until the first. So there has to be like two modes. One is just request a packet, and the other one is request a range. Or rather, maybe requesting a range. Requesting a range makes sense also for other ranges, but there needs to be one mode which is from these until the first packet, which I don't know what that is. Yeah. The nice thing about going down instead of up is that you can also use that as an estimate to know how many more packets are going to be there, because you know that you always end at 0. Okay, this is fine. You know what? Maybe this could be information about the audio data. That might be cool once we start worrying about audio data, but for now we don't, so that's fine. Oh, here's something interesting. Um, do we increase the packet sequence number when we send multiple chunks, or do we keep the sequence number the same? Huh. I think we should keep the sequence number the same. Hmm. I'm I'm curious to prototype the a packet that represents requesting a frame. Packet sequence number. Mm, I think it should be chunked start and chunked end. Wait, actually, did I do it right? Yeah. Like this. Hmm. I guess that's one way of doing it. I don't know. Okay. Well, we'll see when the time comes for this guy. For now, it's too early. Okay, let's go fix what we broke. Core network. Okay, where are we? Host media sender. So we are sending an actual outgoing packet. Um, So this is stream ID. User ID you can leave undefined, I guess. The CID is also undefined. String type. Voice. There we go. There's no restart in the header. That is true. Yeah, why am I not using the proper utility functions? So data, well, packet, I guess, is gonna be, this goes here, and then we do Awebo media, and now we can do voice, serialize, buff, stream ID, going to be this. Actually, when serializing, we really don't care about the stream ID. We just care about the stream type. Interesting. So this is going to be something we're going to make better now. Okay, so that means that we don't do this anymore. Don't do this anymore. Okay, so this should be it. Run host media receiver. Right. So now we want the client ID. So this is now stream ID dot client ID from client ID. Set the type U30, found U32. Run host media manager. Okay, so this is for opening the stream, for sending an open stream. This is now open path. Client ID. Open path. Why? Client ID nonce. There you go. Client ID. Right now here we don't have this information, unfortunately, because we kind of don't know it yet. Yeah, we kind of don't know it yet. Hmm. Yeah, I'm not gonna be able to make this work tonight on stream. This is gonna be something that I need to work on my own because it requires a bigger, deeper refactoring. It's fine. We can pass at least the nonce. What else do we pass? We pass out. And actually, this is like this. So that means that we're gonna be more precise. We're gonna take pointer to um, size of header plus size of open path. Const 8, no more const. There we go. So this is out. We can catch unreachable because we expect the right size. I don't know why I'm doing buff print instead of doing mem copy. Hmm. Yeah, OpenPath shouldn't have this problem. Actually, voice could also avoid this problem, but no, I can't. We can assert that this guy has, I don't know, like 200 bytes or something, but it's fine. Okay, so for now we can do this, I guess, kind of to fake it out. What's out? You know what? This might at this point might even just return it. Fuck it. There you go. Yeah, has been fixed. No more need for this. Wow. No more ooming. That is a nice improvement, actually. Holy shit. Okay, so this is it on our end. Then yeah, this is good actually. So where do we parse a packet now here? Data message header, bytes as value. Okay, so we're not really doing a good job here. So what we should be doing is receive, and then we do const header const body equals Awebo protocol header dot parse, right? Yeah. M.data. So with this, we can immediately look at the caller ID if we want to. But before that, I guess we want to look also at what kind of packet we are getting. Maybe. Get active caller, drop packets otherwise. And here, so this is going to be this. This is going to be switch header dot stream ID dot um what do they call this stuff? Uh this sucks. There's IDs stream is repeated too many times. I guess we can change this to kind. So the stream ID contains kind. Lightname, thank you for the Prime sub. Thank you very much. Okay, so stream ID dot kind, and then it's voice. Then great. This is what we want to do. Although first we want to parse voice comma const data equals Awebo protocol media voice dot parse body. And so this becomes voice dot restart header dot sequence and data. There we go. There we go. And this stuff also goes in here. Okay. This is nice. This is very nice. What about other things to do? Implement support for other streams. Okay, so far so good. Media connection details should not add that. Cannot be cast from stream kind. Enum to int. Int from enum. Protocol media header. Oh, right. Or else return, I guess. Continue. Expected U16 found U30. Yeah, about that. It's a U30 now. But if we want to make this a U30, let's make it a U32 for simplicity. So now the server wants to stuff in here client TCP connected at, which we were using as an ID. This sucks. We don't do that anymore. Don't look at my secret nonce. Number chosen at random. Wait, me guaranteed to be random. Okay, next problem. Open stream. Yeah, this is open path. Why does rename send me back there? Dude, I want to go here. Why? Expected type U30, found U32. Open stream. Okay, so here the problem is that this field doesn't exist. Yeah, so this is the part that is problematic. Basically, I need to introduce the concept of a client ID, which I have never introduced. I kind of only half-assed. And we need now to get a real client ID. I think I'm gonna stop the stream here. So we did some work, almost 5 hours of work. That's not bad. Um, but this now requires me to stop for a moment, think things through. I'm not gonna implement this 100% correct yet because I think there are still some prerequisites that are missing to really be able to implement this 100%. But I'm basically gonna move the hack from very close to the call code to further away, essentially. And then I don't know, and then we'll see. So once this refactoring is done, we're gonna be ready for video essentially. Do. Off topic question: is DVUI already robust for web applications, at least for Awebo? Um, so I think the answer is yes. Um, DVUI is fine for the web as far as I can tell. Um, for Awebo specifically, Awebo is really a web last type of project, like the exact opposite of a web first project. So right now, I have in mind this half baked idea of taking the current client implementation and run it in the web. And DVUI is not a problem because DVUI can target WebAssembly with WebGL. So that is, it has a backend for that. And there is, as far as I can tell, absolutely no problem at all whatsoever with it. The problem is actually the rest of the stuff. It's the fact that I'm doing multi-threading and WASM support for multi-threading is weird. Um, and then I would need to fake UDP and TCP using a thing called web transport. So yeah, so it's basically I have other issues. DVUI is 100% not one of them. So so for Awebo specifically, DVUI is fine, but I have other blockers. For a general web application, I think it would be fine, but you need to be aware that what you're making is going to be, you know, a WebGL canvas where DVUI draws inside of it, and it will do everything. It will do, you know, text selection for you, etc., focus management for the various widgets, but there's not going to be any DOM. So I would argue that for some applications, that's fine. For some others, that might be not fine. So just be aware of this. Other than that, the DVUI has been just a pleasure to work with. So no problem. So yeah. Thank you everybody for hanging out. I'll figure out all the wiring work to shuffle things around and produce a client ID to connect the clients. And then we're gonna have to worry about the machinery to collect packet chunks and reconstruct a full packet out of it. Which, by the way, you know what we might want to use those 2 free bytes for? For example, maybe we should write down what the maximum size of um, a packet is. So that way, when you're reconstructing a packet, you don't keep getting surprised by an ever increasing packet, but you know upfront how much memory, contiguous memory you're gonna need for that packet. Maybe that might be good. Maybe that might be useless because you end up using like a pool of buffers that you keep reusing, and so after a while, that knowledge is not as important. So you might as well just use those bytes for data. I don't know. We'll see. In any case, thank you all for hanging out. Let me see if there's any Zig streamer that I should raid. If not, I'm going to be lazy and call it a day. Oh, there's Lucas. I'll send you to Lucas Develops. So have fun. And I'll see you next time. See you all.